In this video, we're simply going to look at sets. So this video aims at helping you revise everything that you need to know under sets. Now I'll give a brief summary of everything that you discussed under sets, and I will be bringing up the nuggets that are needed for every question before we solve it. So the summary that you had on sets, remember that sets had three parts. You looked at the number line and intervals and everything else. I'll just say the real number line. Then you talked about complex numbers. And then you ended up talking about surds. That's what you had under sets. So on the number line, there are operations that were relevant that you needed to do. Remember, we talked about intervals. There are open, closed, half open and half closed intervals. And also there are a few rules that you discussed on how sets can be related. Remember, you had things like this being the same as that, and we say complement of another complement. This is just the original set. So all those rules that you did under sets. Complex numbers, remember, these are just all numbers that look like this in the form of that, or they'll give you x plus iy. And surds, anything that has a square root that you're able to simplify or not, it's simply a surd. So now look at the first question. So I compiled a few questions from recent papers. So I started with the 2024 paper. So the first question here is saying, express the 22.3 minus 5.25 in the form of a over b, where a and b are integers. This is from the 2024 Math 1120 exam. So I already have this whole file. So these are the questions that we're going to be discussing. So we have the first question, we have the second question here. We're going to ignore this. I mistakenly added a topic from polynomials, so we are going to ignore this part. We'll just do A and B2. This is the 2024 1120 paper. We have the 2022 1100 paper, and we have the 1120 2023 question on sets, and we have the 1100 2023 question on sets. Then lastly, we have the other one on 2018, and then there's a bonus that I added as a quiz. This is the questions I added here. They're also on ignoring this one, of course, which is on functions. So the other part is on sets. So I already have the whole file, so I'm just going to be solving and highlighting or showcasing the question that I'm doing. So the question that I'll be solving first here will be the 2024 Math 1120. That's the first question we are starting with. So this is the question I'm going to start with. Yeah, so here we go. So the first question there is asking us to convert 22.3. So question 1, so this is A1. So there's a 22.3 with repeating minus, there's a 5.25, and the bar is only on the 3 from the first part. There is no bar on the second part. So we're simply going to change this. So we let x be equal to 22.3 bar. Then we can call this equation 1 because the repeating digit is alone after the point. So we're going to call this equation 1. Then we're going to move the repeating digit on the other side by multiplying this whole expression by 10, because we just have to move the point by one step. So the 10 affects both sides. This will be 2, 2, 3 with the 3 here, because there are a lot of these 3's here, right? There are a lot of them. So despite you moving 1 on the other side, these 3 that has come here, there are still plenty of them. So we have to still show this. Then we have to subtract. We say equation 2 minus equation 1. We're going to have this cancels. Then this is going to give us, we're saying 223 minus 22. This is 10x. Then this is just 1x. When we subtract, we get a 1, we get a 0, we get this. This is just going to be 9. We divide by 9. So the first part here is 201 over 9, then minus. This has no bar, meaning it's a perfect type of decimal number. We're simply going to multiply. This is that. There's a 1 down. we multiply by 100, we multiply by 100 to get rid of the point. This is going to be 525 over 100. We can reduce it, so please let me remove this. So we're having a 201 over 9 minus, this is the same as 25 into 525. That's simply going to give us a 21. Then we have over a 4. Then here we can simply reduce this. This is going to be the same as 36. Then this is 804 minus, this is going to be 9. That's going to be 18. When you subtract, what do we get? So we're having 804 minus 189. There's a 1 there, that's going to give us a 5. That's going to give us a 9, by the way. There's a 7 there. This will be a 1. To be a 1, is it? Am I mistaken? Oh, this is a 7, sorry. 7, that's 6, right? This is 615. Then we're having a 36. So we can simply reduce this by a 3. A 3 there is 2. This is going to give us 205. And that's a 1 and 2. So this is the final answer. This is what was needed, 205 over 12, where your A is 205 and your B is simply 12. So that's what we do for the first case, the first question I mean. So this guy here is done. The second one, they're saying express the complex number in the form of A plus BI. The complex number here is negative 2 plus 4i over 1 plus 3i plus 2 minus I to the power 3. So you can pause the video and attempt it first before we do it together. Negative 2 plus 4i. Then we are having a 1 plus 3i. Then plus, there's a 2 minus I to the power 3. Then we can expand this part. So 2 minus I to the power 3 has to multiply itself 3 times. So this minus that again, so it has to multiply itself 3 times. So you have to multiply these times that. The answer you get again multiply by that. So we'll do it step by step. So 2 times 2, that's going to be 4. 2 times I, that's negative 2i, right? Then negative I times 2, that's going to be negative 2i. Negative I times negative I, that's going to give us a positive I squared. Then we have a 2 minus I. Then this, remember that I squared is equal to negative 1 under complex numbers. So we're going to have 4 minus 4i, then minus 1. We have 2 minus I. This will be the same as 3 minus 4i, multiplying 2 minus I. Then this will be 6 minus 3i minus 8i plus 4i squared. This will just be 2 minus 11i. That's what I'm getting. Remember that I squared is negative 1, so that's where we're replacing. This is going to be negative 4, so 6 minus 4, that's where the 2 is coming from. Yeah, so please don't forget this. I squared is always going to be equal to a negative 1 under complex numbers. So now we can rewrite this. 4i, there's a 1 plus 3i, then this is now plus 2 minus 11i. We can put a 1 there. We add this. The common denominator is 1 plus 3i. We can multiply. This is going to be 1 multiplying negative 2 plus 4i. Then we have plus. There is 2 minus 11i multiplying 1 plus 3i. And this is going to be negative 2 plus 4i, then plus a 2 plus a 6i. I'm multiplying everything by 2, then multiply everything by the 11. This is going to give us negative 33i squared. Down we just have 1 plus 3i. So this is now going to be, we see things that are able to cancel here. So you see that the negative 2 can cancel with these 2. We're having 4. 4 plus 6, that's going to be 10. 10 minus 11, that's negative 1. So we have negative I, then plus a 33, because this is going to be I squared is negative 1, right? So now negative 1 times negative 33, that's positive 33. Down, we just have 1 plus 3i. We multiply by the conjugate of the denominator. So if we multiply with the conjugate of the denominator, this is multiplication, by the way, a dot. We're multiplying the guys on top. That's negative I times 1. That's negative I. That's going to give us a positive 3i squared. Then we are having 33 times this. That's going to give us a 33. Then minus a 99i. Then down, we're just going to have 1 minus 3i plus 3i. Then minus 9i squared. This is going to give us, this is negative this, that's going to give us negative 100i. Then this is going to be negative, that's going to be plus 30. Then down, we're just going to get a 10. Because I squared, this part cancels. I squared is negative 1. Negative 1 times negative 9, that's a 9. 9 plus 1, that's where the 10 is coming from. So the guy on top can be rewritten to be the same as 30 minus 100i. We just start with the real part. Then we divide. This is the same as 30 over 10 minus 100i over 10. So this is the same as 3 minus 10i. So this is basically what they wanted. This answers the second question there. So that's our answer to this question. That was costing us 4 marks. That's what you have. Then look at number B. Number B, they have given us 2 sets. There's A, B, then there's C. And the universal set is from negative 10 to 7. It's closed on both ends. They want us to display the following expressions on the number line. So this can also be simplified to be, let me just simplify this. So this here is the same as, we have C, okay. So the first one is a normal interval, and the second one here is also a normal interval, but C is a discrete set. Whenever you see these brackets here, the curly brackets that are here, always remember that this is a discrete set. And how we show a discrete set is just by putting dots on those numbers that have been given. Yeah, so to show A intersection C complement, we're simply going to have a number line that ranges from negative 10 up to negative 10 to positive 7, I mean. So we are having, this is negative 10 here. So we have a negative 10 and we have a 7 on the other side. This is a 7 and it's also closed this side. So A is given to be from negative 6, or we can start with C first. So C is a set that looks like this. There's a 6, there's a 7. These are just going to be dots. That's what you have. This is your C. That's what we mean by a discrete set. Now, what's the complement of this set here? If I may use a different color. Complement means anything that is outside, everything that's outside actually. This is going to be everything except from negative 3, 6, and 7. So it's everything else. So now that I'm showing it like this, the guy in red is C complement. Then I'm going to use blue to indicate set A. So set A is from negative 6. Set A is from negative 6 up to 4. 4 is just here. So this is going to be your A. This is what you're having. And it's closed at 4 and open at negative 6. So this is what you're having as your A. So this is your A here. So now they're asking for A intersection C complement. So where are we seeing A being parallel to C complement? It's just here. Then here it's open. Then we come here again. We show this part. So meaning the answer is from open negative 6 to negative 3, union open at negative 3, and 4 closed. This is going to be your answer for the first case. Hope this makes sense. For C complement, we have elements negative 3, 6, and 7. that are elements in set C. So the complement will mean everything else except these same three numbers. That's the reason why we're having this red line going from -10 to +7. The whole thing except we're leaving holes or openings at -3, 6, and 7 because these guys are excluded. They are not outside. They are inside C, right? We need everything outside C. Then A is just here. Then we are not adding -3 in their intersection because -3 is not in C complement, but it's there in what? In A. So no wonder we're leaving it open. It's just going to be a boundary separating the two portions of A intersection C complement. So we have this piece here plus this guy here. So that's your first part. Then the second part, they're asking for C intersection B intersection A complement. That's what they want. So just right here, I'll come up with A complement so that we don't waste a lot of time. So A complement is supposed to run from -6 going this side up to there. That's A complement, the first piece. The other piece will run from there up to there. That's A complement. Yeah, so the guy in blue is simply your A complement. I will erase A. That's what you're having. Then we already had C. Remember what C was? So C was already here. Yeah, so this was C already. This was C. Then we are looking for B. We're looking for how to plot B. B is simply going to be, let me use paper to indicate B. B is ranging from -10 from right here up to 1. So up to 1, somewhere here in between. So B is somewhere here. The guy in purple, so this is closed here at 1. And also ranges from 2 to 7. Again from 2. So let me say 2. Is open at 2, then goes to 7, and it's closed. Now we're looking for the guy in purple is B. This is B. The guy in purple is B. Then we're looking for a portion where the three things are going to intersect. You're seeing the blue. Where can you see the blue, the red, and the purple? The only time is here. You can see them here at 6. They are all touching there. They are all including 6, and also at 7. There's nowhere else where the three guys are appearing. So meaning the answer to this is going to be a discrete set, which is just 6, 7. So this is what you get. This answers the last question here on question 1. Hope this makes sense. Then look at the next question. The next question here is from the 1100 2024 paper. So the full video is there on the channel. You can just scroll the 2024 paper. The whole paper is solved. They're saying consider the real number line to be the universal set, and we have sets X and Y and Z. This is what they're asking for us to do. So we're simply going to have the first thing they're asking is X complement and Y complement. This we know can be written as X complement intersection Y complement. This will be X complement intersection Y. So this is what we are looking for when we know to say the X complement. We know X is from negative infinity to 5. Initially this was the set X. This is X. Now the complement of this will just be open going this side. So this is your X complement, we know that. Then Y is a set from -3, that's -3 to 7. -3 to 7, and it's closed at 7, and it's open this side. We're looking for the intersection, so the intersection is just going to be from 5 to, this is going to be open at 5 to 7, closed. So that's the answer for the first case. Then the second thing they want us to get, they want Z. The second thing they want us to get is Z intersection X minus Y. Then there's a complement outside. This here is the same as Z intersection X intersection Y complement. This is the same as Z intersection X complement union Y. That's what you have. Now we already have X complement here. X complement was everything that we got from 5 up to positive infinity. That's what we have. Then they want us to put a union between these two, which is x and y. Remember, this is x and this is your y. So the intersection here, the union is going to be everything. So the union is just everything from negative 3 up to positive infinity. We are trying to intersect this with a z, and our z is from 10 to positive infinity. So z is from 10, from here going this side. That's simply your z, and it's open at 10. So what's the intersection here going to be? Because this is now 10 to positive infinity, intersecting negative 3 to positive infinity. So the answer here is simply going to be 10 to positive infinity. Yeah, because this guy here is a subset of this, right? So this is going to be our answer. Our answer will just be from 10 going this side. That's the only time when we see the red one and the blue one being parallel to each other. That's what you have. So that answers the next question here, which is this whole question there is answered. We have to answer this last one here. They're saying express this number as a fraction in the form of a over b, where a and b are integers. So you can pause the video first and attempt it before we do it together. They're saying negative 2, 5, 1, then 3, 2. The bar is on 3 and 2. That's what we want. So we can let x be equal to this number, 5, 1, 3, 2. We can't call this equation 1 because we have numbers after the point that are not part of the repeating bar here. So we have to move the point here, meaning we have to multiply by 100. So it's going to be 100x is equal to negative 251.32 with a bar. This is equation 1. Then we multiply this equation 1 now by 100 again to get the repeating digits to go on the other side. This is now going to be 10,000x is equal to negative 251.32, then 32. This is equation 2. We find the difference here. These parts are going to cancel. We're having negative 251.32 minus, this is a 10,000. Then we have 100. X is equal to, we are having a 151 negative. So we're trying to get the difference. Yeah, so as I'm trying to subtract this, this is going to be 0, 0, 100, and this is 99x. Here we're just going to get a 1. Here we're simply going to get, this is going to be 0. Put a 1 there. That's going to give us 8. And this is going to be, get a 4 there. We put a 1 there. That's going to give us, this is a 2, right? This is a 2. So this is going to be 8. Then 4, then 2. This is negative 9900. Let me divide by that. Yeah, so this is just going to give us x is equal to negative 24881 divided by 99 and zeros. This is what we get. So that's going to be your answer for the last question here. This is supposed to be your answer here. The next question here is asking us to show the described set notation in a shaded Venn diagram. They want us to shade it. They're saying the sets A, B, and C all intersect. E is a universal set. So we're taking the best case scenario that they've told us here to say these guys actually have an intersection. So this is a question that I'll be solving. You can just screenshot this. So here is what we are going to get. We're having the first one. So question A1, they want us to shade the notation, which is B intersection. This is A complement union C. There's a complement there, and there's another complement outside. So we'll try to simplify this first by introducing the complement everywhere. This is going to be B complement. That's going to be A intersection that. Hope by now you know to say when you introduce the complement, the sign always flips. It was intersection, it becomes union, complement, and the complement, they cancel. This becomes intersection, this cancels. So we're having a Venn diagram that looks like this. So we can just say we have A, we have B, and we have C. This is A, B, and C. They want us to shade this region that is shown by this particular set. So to be safe, we'll always use numbers. So I'll just pick numbers. Let me use something else. So here there's a 3, there's a 4, let me say 5, let's say 6, let's say 7, let's say 8. So B complement, what is outside B? The numbers outside B are simply 1, 2, 6, and 7. That's what's outside B. Then the numbers in the intersection of A and C. A and C, what is common between A and C is just 5 and 6, right? So then what's common between these? Oh, there's it's union, sorry. This is union. So union brings back everything I mean. That's 1, 2, that's 5, that's 6, then that's 7. So we're shading where there's 1. So we need to shade this area here outside. Where there's 1, we shade the area. And the E is a universal set, so we need to put the E there. So this part has to be shaded. Where there's 1, where there's a 2, we have to shade as well. Where there's a 5, we have to shade as well. Where there's a 6, we need to shade. Where there's a 7, we need to shade. So technically, this is going to be, we can remove the numbers now. The numbers were just guiding us. So this is going to be the shaded region that denotes this particular set here. So hope this makes a bit of some sense. Using numbers is always a certain way, a sure way of you getting the correct thing. Yeah, because you never go wrong whenever you use numbers. Then the next question there is asking us to simplify. They're saying, given that two sets are disjoint, by disjoint we just mean they are separate, right? They have no intersection. We have A and B. They want us to simplify A union B, then minus B. So we know what this becomes. This is A union B, then intersection B complement. So we can put a 1 there, put a 2, put a 3. So A union B is just 2 and 3, right? Then intersect it with B complement is 1 and 2. So what's common here is just going to be 2, which happens to be your A. So this, your answer here is just going to be A. Again, numbers are helping us here. So numbers just make sure that you do the correct thing. Yeah, so this is just going to be our answer. That's for this question here. So answer the first one and the second one. Then here again, they want us to simplify this. They want us to break it down until we cannot break it any further. So this is simply P. They're saying there's a P intersection P minus Q. Then there's a complement. This will be P intersection Q complement. There's a complement outside. We can bring the complement inside. That's going to be like this. Then this is going to be P intersection P complement. Then union P intersection Q. This here is going to be an empty set, union P intersection Q. This is just going to be P intersection Q. We cannot simplify this further because we don't know how P and Q are related. Yeah, so this is what we're going to get. Remember that any set intersecting its own complement is always an empty set. Then any set, union an empty set, is that same particular set. So that's what we're getting here. Hope that's okay. The next one is on the number line, so I'll skip this because it's similar to what we did. And this is even way easy. Yeah, because you know how to handle a discrete set now. They've given us this, so please try this. You can just try it and confirm with me on WhatsApp. So this is just to enhance your solving skills. Yeah, so you can try this. I'll leave this for you. It has 3 questions. We need to display them on the number line. Take note that the universal set is negative 11 to 10. Yeah, then number C is under Surds. So C, they've given us a Surd that is the root of 25 plus root of 50 minus root of 98 over 1 plus root of 2. They want the answer to be in the form of P plus Q root 2, meaning they know that everything is going to be divisible by 2, that is under the square root. So we have to use 2 as our hint. So we're having root of 25, then we're having plus root of 50, then minus root of 98, then down we're just having 1 plus root of 2. So the square root of 25 is just 5. The square root of 50 is the same as 25 by 2, then minus. This guy here is the same as, this is going to be a 49 if I'm not mistaken. Then we have 1 plus root of 2. So on top you're going to get a 5. Then you're going to get a 5 root 2 minus a 7 root 2. Then a 1 plus root 2. This will just be 5 minus 2 root 2 over 1 plus root 2. Then now we multiply with the conjugate of the denominator. Then this will just turn out to be 5 minus 5 root 2 minus 2 root 2. This is going to be minus 4 because we are having this times that negative. This is going to be positive actually. Negative and negative, that's positive. Down part you just get this. This is going to be a 9 minus 7 root 2. This is a negative 1. So this right here is the same as negative 9 plus a 7 root 2. So where your P is negative 9 and your Q, so this is your P, then your Q is just the coefficient of root 2, which is just a 7. Yeah, so this is what you're supposed to get. For C1, you should get this. Then for C2, they've given us a complex number. The question that follows next, they're saying Z is equal to, there's 3 minus 2i, then down, they've given us 1 plus I to the power 2. They want this in the form of x plus iy. So this is just going to be 1 plus 2i plus I squared. This is the same as 3 minus 2i. Then you're having a 2i down. This is the same as if we multiply by negative 2i and also negative 2i. This is going to be negative 6i. Then plus, this is going to be 4i squared. Down you just get a negative 4i squared. This here is the same as negative 6i minus 4 over 4. Then this will just be, we'll say negative 6i over 4 minus 4 over 4. This will just tend to be, this is negative 1 minus 3 over 2i. So this means your x is negative 1 and your y is negative 3 over 2. So in case you're wondering what I've done here, I've just multiplied the bottom part. So please take note in case I've used a shortcut that's confusing. Let me just use the long route. So we are having 3 minus 2i. At the bottom we needed to have 1 plus I and 1 plus I. So when we multiply these guys here, multiply the down part, this is 3 minus 2i. When you multiply the bottom part, you needed 1 plus I, then minus, or plus I squared, I mean. Then this is simply going to give you 3 minus 2i. Now this is a negative 1 and this negative 1, so these guys will tend to go, giving us what? 2i, right? So here, you can write this the same as the way we've done. This is the same as 3. To just make sure that you see what happened. This is the same as 0 plus 2i. The conjugate of this is the same as 0 minus 2i, and the conjugate of this is, I mean, we're multiplying by that. So this is just now giving us the 6i, then plus the 4i squared. Then down, that's why we got the negative 4i squared. Yeah, so this is basically how we landed this side. Because I squared is negative 1, so on top it's the same as you have negative 4 minus 6i over 4. Then we divide by 2 throughout. This is just going to be negative 4 over 4 minus 6 over 4i. This is the negative 1. 2 there is a 3, 2 there is a 2. So this is what we got. This is basically what we did. So if there's no real part, like how we remained with 2i, then the real part is going to be represented by 0. The same applies if there's no imaginary part. So this is basically what you have. So we'll answer this question as well. Then this as well, you can attempt it. We've done something like this. Yeah, so your x is just going to be the same as, there's going to be 10x as 31.43. Then there's going to be this guy, which is equal to 3143, then 0.43. Cancel this, so we're just having a 2. That's going to be a 213. Okay, so this is going to be 0, that's going to be 99, 0. So this is supposed to give you 9, 9, like this. This is supposed to be your A over B, so I hope this makes sense. Then look at this question here in the 2023 paper for 1120. Previously, they gave us the notation they wanted us to shed. Now they've given us the shaded region. They want the notation that represents this part here. So I'll put numbers as well, 2, 3, up to 4. So we have this. So we know the middle part is simply A intersection B. That's what is 3. This is, we know this. Yeah, so complement, this will give us 1, 2, and 4. We know what this is. Then we also know what A union B union C is. This is just going to give us what? 2. Or I mean the complement of this. The complement here is what? If I put a complement here, A union B union C is 2, 3, 4. Then the complement is just 1, right? So I'm having these two sets. I need to subtract them. So this set minus 1. So that's A intersection B complement minus A union B union C complement. This is 2 and 4. So this is the set that was needed. This guy here is the answer to this question. They've already shaded it for us. We're looking for a notation that will show the shaded region, which is containing 2 and 4. Again, numbers are the best thing to use here. You'll never go wrong when it comes to the numbers. Yeah, so this is, you can do it however way you try to do it. The answer has to make sense. There is no one method or one fixated way of going about it. Yeah, then here they want us to get B minus A. So this is the same as B intersection A complement. Again, this is on the number line. You can attempt this and share with me your answer. Then this here is on complex numbers. They are saying, given that X and Y are real numbers, solve for X and Y in the equation. So this is what they want us to do. So how do we relate these two equations? We're told that everything is equated to 1. So let me just simplify this guy for you here. This is root of 7 plus 1. Then this is root of 7 plus 1. You can multiply the top part. That's going to be a 7. Then plus root of 7. Then you're going to get a root of 7 plus a 1. Then down you just get a 7 and minus 1. This will be 8 plus 2 root 7. This will be 6. You divide everything by 2. That's going to be 4 over 3. Then plus 1 over 3 root 7. So this is your A, this is your B. That's the answer for the second one. So now we're trying to do this guy here on complex numbers. So I'll rewrite it. So this is going to be, they've given you 1 over X plus Y that. Then this is plus, there's 1 over 1 plus 3I is equal to what? 1. So take note that Z is equal to X plus IY. That's what you should know. So this here is the same as 1 over X plus YI is equal to 1 minus 1 plus 3I. There's a 1 down here. This is 1 X plus YI is equal to 1 plus 3I. Then there is a 1 plus 3I, then minus 1. This is just going to be X plus YI is equal to, there's a 3I, then there's a 1 plus 3I. We can simply cross multiply here. When you cross multiply, this will just give you 3I Z. So I'm putting Z because this guy here down is the same as Z, is equal to 1 plus 3I. Then I'm going to divide by 3I and also by 3I. So Z is simply 1 plus 3I over 0 plus 3I, because it's just 3I, right? We said whenever there's no real part, we can indicate putting 0 in front. So this is 0 plus 3I. We conjugate, this is 0 minus 3I, then 0 minus 3I. This, remember, it's X. This will be 0 everything, negative 3I. Then that's going to be positive 9. Then down, we're just getting a 9. So this is now going to turn out to be 9 over 9, then minus 3I over 9. This will just be 1 minus 1 over 3I, meaning X is equal to 1 and Y is equal to 1 over 3. So these are the answers that they wanted. So this is basically what you do. This is what you have. Yeah, so I shared the whole thing. This is just to help you be reminded of the concepts that you need. So there are a bunch of questions that you can just try here. Try them, then this is the best way you can learn this and revise, is for you to solve. Practice. Yeah, so you can attempt this for those that have not yet attempted, and then just share with me your answers. Then there were questions that someone had asked in the group. Mapalo had asked a few questions. Let me just look at them. So the first question that you asked, Mapalo, you asked a question that says root of 5 minus 3, what's a conjugate? The answer here is just changing the sign on the middle. That's what the bar means. This is just a root of 5 plus 3. That's basically what it means. Then the next one is changing the, so they give you, initially, the idea of changing the sign, or rather rationalizing something like the conjugate of here, of Surds. Initially, someone will tell you to say, we need to change the sign of the part that has a square root. So someone will say this is supposed to be negative 5, then minus 3. The same way that you deal with complex numbers. Whether you put the complex number in front or not, we're just saying the conjugate of this is what? Negative 2i, then plus 3. It's the same also here under Surds. But the reason why you can also have the other option of just changing the sign on the middle is because either way is when you multiply this and its own conjugate, whether this 5 plus 3, whether this or this guy, the square root gets to disappear. Yeah, so whichever between the two is technically going to be correct, because we're just looking for the conjugate. An expression that will eliminate the square root if we were to multiply those two things. So in the next question that you asked, which is root of 5 plus root of 3, conjugate, we just say change the sign on the middle, which is just this. It's just straightforward. Yeah, so for Surds, I'll just say be changing the sign on the middle. Then your question 2 was to simplify the root of 10 over the root of 45. If I'm saying this properly, this is the same as that. So if they put this, we can get rid of it by flipping it to be 45 over 10. Let me say this guy here. So there's root of 10. So you notice that I've gotten rid of this, right? If I give you a over b to the power negative 1, this is the same as 1 over a over b, right? Which is the same as 1 divided by a over b, which can be written as 1 times b over a, which now becomes b over a. That's how you get rid of the negative. Hope that makes sense. So now we're rewriting this because there's another part here that you added. So you added something like what, a plus 128 plus root of 128. So I'm adding the 128. So this here is the same as the square root of, this is just 45 over 10. Then plus root of 128. So here we're just going to write this as the square root, because 5 there can go there, and what, 5 into that's 9. 5 there is 2, so this is the same as root of 5. Yeah, so we can just break it down here. Then we have plus, we're having a 128, which is the same as 64 by 2, so this will be 8 root of 2. We're having this. The common denominator is root of 2. This is just going to be a 3, plus this is going to be 8 and a 2. This is just going to be so we're having, this is 16, 17, 18, 19. This is 19 over root 2. We can just multiply by root 2 and root 2. This now becomes 19 root 2 over a 2. That's how you go about this on your second question there. Then the next one you asked was something that has to do with the negative 1 plus the square root of 125, then plus 1. So you can pause the video first, rationalize this part. This is 1 plus root of 5, 1 plus root of 5. This is negative 1 plus. This is the same as 5 by, is it 5 by 5 or something? 5 by 5, that's 25. Is it 5 by, this is 124 divided by 5, that's a 25. So we're just going to say 5 root 5, because this alone is 25 times 5, right? Yeah, so then this here, when you rationalize this other part to give you, so just give you negative 4 if I'm not mistaken. Then we are just trying to combine everything here That's what we're trying to do. So the common denominator is negative 4. This is going to be a 4. This is going to be negative 20 root 5. Then this is 1 plus root 5. Then this will end up being a 5. Then this is going to give us a negative 15 root 5. This is a negative 4. Yeah, so this, this is going to be negative 20 and 1. That's going to give us 19 there. Yeah, so just remain with that. That's on your second question. Then the other one is on complex numbers. So these ones here, you just have to express them the way that they were given and simplify them. You have 3i minus 2. You have 2i minus 6. Then you're saying it's equal to 3a. Then plus 3. Then b minus 1. There's an I there. So here we just solve them the way they are. Just expand this part and also solve this other part. We're just going to cross multiply rather. So we have 3i minus 2. This is 2. 2i minus 6 is equal to 3a. Then we are having plus 3bi. Then minus 3i. That's what you're going to get. Then now cross multiply this. When you cross multiply, you are simply getting a 3i minus 2 is equal to negative 2i. I mean 2i multiplies everything. That's going to give us a 6ai. Then this is going to be negative a 6b. Then this is going to be, because the I and the I became what? Negative 1. That's the reason I'm putting a negative here. Then the 2i times negative 3i, that's going to be a positive 6. Then again, I start with a negative 6. That's going to be 18a minus 18bi. Then plus, that's going to be 18i. So here, equate the things that are same. Things that have I, I'll get the 3. I'll get the 6a. I'll get the minus 18b. I'll get them plus 18. So here I take this on the other side, that's going to be negative 15. Or I divide everything by 3. This is going to be 2a, 6b plus 6. So this gives us an equation which is just 2a minus 6b is equal to negative 5. That's your first equation. Getting the imaginary things, these guys with I, that's what I got. Then I'm going to get the things that have real things, the real things without the I, that's negative 2. Negative 2 is equal to negative 6b plus 6, then minus 18a. We can divide it throughout by 2. That's going to be negative 1. Then divide by 2, that's 3b, that's 3, then minus, that's 9. Then from here, we can make up an equation, or there's 9a. Yeah, we make up the equation, which is just going to be negative 9a minus 3b is equal to a negative 4. We solve these guys simultaneously by simply making these two parts to be the same. So I'll multiply this equation by, we can use by substitution here. So we're having, I can just use substitution. This is going to be, so which is just us making a the subject there. So we're going to have 2a is equal to negative 5 plus 6b, then divide by 2. Yeah, so this is just going to give us a is equal to that. We replace it there. So now we're going to get a negative 9. We put negative 5 plus 6b over a 2 minus 3b is equal to negative 4. So this is now going to give us a 45. Then this is 9. This is going to give us negative. So that's 45. That's going to be 6 by 9. So this is giving us a negative 54b. Then we're having a 2 down. Minus 3b is equal to negative 4. We're simply going to say 1. Then we multiply throughout by 2. We can just get rid of the 2 down. This is going to be a 45 minus 54b. Then minus a 6b is equal to negative 8. Then this here is just going to be 45 goes the other side. This is going to give us a negative 60b is equal to the 45 goes on the other side. So we're having a 45 plus 8. That's going to give us a 53, which is negative, of course. The negative 60, negative 60. So b is just 53 over 60. Then we use it to get our a, because remember we said our a is equal to this. A is equal to negative 5 plus 6b over 2. We just replace the 53 over 60 there, then we solve it. Yeah, so that's how we're going to get it. That's what you do for the question that you asked, the second last question you asked. Then the last question there, Mapalo, you asked to say 2 over I, then you have minus 2b, then plus I to the power 3 is equal to I plus A over I, then plus B. It's the same thing. This, first of all, you know what I squared is? It's -1. So I to the power 3 is the same as I squared and I, to make them the 3 of them. So this is a -1, -1 times I. So it should be okay if we say this is the same as -I is equal to I plus A over I, then plus a B. So to avoid getting fractions, I'm going to multiply everything by I to eliminate this I that you're seeing at the bottom. So this is going to be 2 minus 2bi, then this will be I squared, this will be I plus A, this will be bi. I'm multiplying everything by I. Then this is going to be 2 bi, this is plus 1 is equal to I plus A plus bi. Then from here, we're going to get the real things. The real things is simply 2 plus 1, that's a 3, is equal to A. So already you got your A. Then we have -2. The coefficients of I is this part. There's a 1, then there's a B. Right? This is what is going to give you what? -3b is equal to 1, meaning B is just -1 over 3. So you get your A, you get your B. Yeah, so this is what you have to get. Okay, so hope this is helpful enough. So please make sure that you utilize the holiday to answer your tutorial sheets. You shouldn't have anything unturned from semester 1. That's the only way you get to progress and have less stress in semester 2. So thank you so much for watching. If you have any questions, the number is on the description. You should be able to contact and consult.